You get ready. Okay, hope we can continue with what we are discussing in the previous period. That last question we discussed, is it clear? Previous period we did some questions based on 5 plus 55, 5. Okay, that question, last one, is it clear? Okay, shall we move on to the next topic? Okay. Anaga and also she's joining now. Okay, write the next heading, geometric mean. Next heading is geometric mean. So what we have learned about arithmetic mean? What you have learned about arithmetic mean? In arithmetic mean, what you have learned? 3 numbers A, B, C are said to be in arithmetic mean if what we learned? If 3 numbers A, B, C are in arithmetic mean, what we discussed in arithmetic mean, we okay, test paper and all is over. What we learned? If 3 numbers, if A, B, C are in AP, then B is given by A plus C by 2. Is that no? And B is said to be the arithmetic mean of A and C. B is the arithmetic mean of A and C. And we discussed that one, between any 2 given numbers, we can insert n numbers. Between any 2 numbers, we can insert n numbers so that the given sequence will become an AP. We are given with 2 numbers means we can insert n arithmetic means between these 2 so that it will become an arithmetic progression. Is or no? Is or no, children, whether we discuss that type of questions? We are given with 2 numbers. If you are given with 2 numbers, we can insert n arithmetic means between these 2 numbers so that the resulting sequence will become an AP. Okay, so that is what we learned in arithmetic progression. Now here we are going to learn about geometric mean and geometric progression. So for that, suppose you are given with 2 numbers A and B. Okay. Suppose you are given with 2 numbers A and B. Okay. Suppose we are given with 2 numbers A and B. Then the geometric mean of A and B is given by geometric mean of A and B is given by root of AB. There we divided by 2, isn't it? Here it is root of AB. You have to take the power. Root of AB. For example, yes, geometric mean of 2 numbers A and B is given by root of AB. Okay, is it okay? For example, suppose you are given the numbers. Okay, suppose you are given with the numbers 2 and 8. Suppose you are given with the numbers 2 and 8. So what is the geometric mean? GM. Geometric mean, we denote it as GM. GM is equal to root of 2 into 8, which is root 16. What is root 16? 4. Root 16 is 4. Therefore, now listen here, children, when we write this 4 between A and B, 2, 8, 4. Is it an AP? Sorry, not AP. Here it is GP. Is it a GP? Okay. Is it a GP? 4 into 2? 8. 2 into 2 is 4. So when we insert the numbers, it will form a GP. Okay, suppose you are given 2 numbers A and B. We can find the geometric mean using the formula root of AB. So that the given number along with this geometric mean will form a geometric progression. Okay, write the next point. Note. Next is note. Suppose we are given with the numbers. A and B. Suppose we are given with the numbers A and B. Suppose we are given with the numbers A and B. We can insert n arithmetic means between A and B. Sorry, not arithmetic, children, geometric. Between A and B, we can insert n geometric means G1, G2, G3, etc. up to Gn, so that the resulting sequence is a geometric progression. Okay, given numbers A and B, we can insert n geometric means between A and B such that the sequence A, G1, G2, etc., Gn, B is a geometric progression. It is a geometric progression. Write the question. Insert two numbers between 1 and 625. Insert two numbers between 1 and 625, so that insert two numbers between 1 and 625, so that the resulting sequence is a geometric progression. So that the resulting sequence is a geometric progression, is a GP. So that the resulting sequence is a GP. Insert two numbers between 1 and 625, so that the resulting sequence is a GP. How to do this? So now listen, children. We are given with the numbers 1 and 625. Okay, so between these two numbers, we insert two numbers. Let us denote that as G1 and G2. We are inserting two numbers. Okay, so let G1 and G2 be the numbers inserted. Okay, so it's inserted. So that when we insert this one, the number of terms will become 4. Is or no? Number of terms will become 4. What is the first term here? 1. And the fourth term, A4 is 625. A4 is so AR cube is 625. So it will be R cube. A is 1, isn't it? So 625. Sorry, children, please change it. Insert numbers between 5 and 625. 5 and 625. It is not 1, 5 and. So what will be R cube? It is 625 by 5. Get this as 125. Therefore, what is R? R is 5. If R is 5, can you find out what is G1 and what is G2? What is G1 and what is G2? What is G1? G1 is the second term, isn't it? G1 is the second term of the GP. So it will be AR. A is here 5. And what is R? R is also 5. So you get 25. What is G2? AR square. A is 5. R is also 5. So 5 into 5 square, which is 125. Therefore, the GP is Therefore, the GP is, what is the geometric progression here? Therefore, the GP is 5, 25, 125, and 625. The GP is 5, 25, 125, 625. Okay, so here we insert two numbers between 5 and 625 so that the resultant sequence will become a geometric progression. Pooja, is it clear, Pooja?
Yes, ma'am.
Mehrin, Alantina? If I give the next question, whether you'll be able to do it. Can you do it by yourself, Roseanne, Tom, Sebastian? Hmm? When we insert two numbers, total number of terms will become 4, isn't it? Suppose I insert 5 numbers between A and B. Suppose I insert 5 numbers between A and B. What will be the total number of terms in the geometric progression? When we insert 5 numbers, total number of, total number of 7. Total number of terms will be 7. Okay, write the next question. Insert 3 numbers between 1 and 256. Insert 3 numbers between 1 and 256. Insert 3 numbers between 1 and 256 so that the resulting sequence is a geometric progression. So I'm going to insert 3 terms, G1, G2, G3. Find out. Try this one. Rahul, is it clear? Rahul, can you try this? Niranjan? Try this one, children. 3 terms, we insert it so that the total number of terms becomes 5, isn't it? The first term is 1 and the 5th term, A5 is 256. Simplify and give me the value of R. What is the value of R? What is the value of R? Navrin? Not finished. Sabrinath, what's the value of R?
4.
4. R is 4. So what are the terms here? G1, Aditya. What is G1? What is G2? What is G3?
4, 16, 64.
4, 16, 64. Okay. Therefore, the GP is 1, 4, 16, 64, 256. Isn't it? Is it correct, Samia? Align?
Yes, ma'am.
Navaneet?
Yes, ma'am.
Okay. Okay, Samia. Navaneet, is it okay?
Yes, ma'am.
Is it over, John Joes? Hmm?
Yes, ma'am.
Write the next one, children. Write the next question. Find the value of n. It's an important question. Mark it as important. Find the value of n so that a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n. A raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is the geometric mean of a and b. Is the geometric mean of a and b. Find the value of n if a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is the geometric mean of a and b. If this is the geometric mean of a and b. How to do this? If this is the geometric mean of a and b. Listen, children, listen, all of you, sit straight. This is an important question. Okay, this model is important. Not this model, this question. Okay, in AP also we have learned one question like this, isn't it? Listen, all of you. So it is given. This is the geometric mean. What we know about the geometric mean of the numbers? Geometric mean of the numbers a and b will be given by root of AB, isn't it? Geometric mean of the numbers a and b is given by root of AB. Therefore, here a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n, it is given as the geometric mean of a and b. So it will be same as root of AB. Is it correct? It is the geometric mean. How will you find the geometric mean of a and b? It is same as root of AB. Now you square on both sides. Okay, in order to remove the root, you square. When we square it, a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n, the whole square is equal to AB. The whole square will be equivalent to AB. Root will get removed. Okay, so next step, you expand it. Okay, what is a raised to n plus 1 the whole square? What is a raised to n plus 1 the whole square? Power to power means? What you will write? What you will write? Power to power means? Yes. What is it? What is a raised to n plus 1 the whole square? Power to power means it is multiplication of the powers. Is it same as a raised to 2 into n plus 1. So first I'll expand it. So when you expand this, you'll get a raised to n plus 1 the whole square, a square, plus 2ab, 2ab plus b square. So b raised to n plus 1 the whole square by a raised to n plus b raised to n the whole square. So it is a square plus 2ab plus b square equal to ab. Up to this, is it okay? Up to this step, is it clear, children? Don't write. I'll give time for copying. First, listen. Is it okay up to this? Navaneet, John Joss.
Yes, ma'am.
Yes,
So now use the property of exponents. Okay. When you use the property of exponents, it will be a raised to 2 into n plus 1 plus 2a raised to n plus 1 b raised to n plus 1 plus b raised to 2 into n plus 1 by, here also denominator, power to power means a raised to 2n plus 2a raised to n b raised to n plus b raised to 2n is equal to ab. Okay. Next step, you cross multiply. Denominator we are taking to other side. Okay, when we take the denominator to other side and we cross multiply, we'll get here the numerator I'm writing like this, a raised to 2n plus 2 plus 2a raised to n plus 1 b raised to n plus 1 plus b raised to 2n plus 2 is equal to, when we cross multiply this, a raised to 2n into ab. So what you will get? A raised to 2n plus 1 into b. Am I correct, Alantina? When we cross multiply it. When we cross multiply, we add the powers, isn't it? We add the powers. So a raised to 2n, already one a is there. So it will become a raised to 2n plus 1 into b. Plus next term, if you take the next term and if you multiply 2 into a raised to n plus 1, b raised to n plus 1. Is it correct? Yes. What is the next term? What is the next term? What will be the next term? Plus, when you cross multiply it, b raised to 2n into ab. Therefore, what you will get? It is b raised to 2n plus 1 into a. Is it correct? When we expand like this, will you be getting like this? Is it clear? When you cross multiply, when you multiply x raised to m into x raised to n is x raised to m plus n. We have to add the powers. So we'll get like this. Is it okay? Now here 2a raised to and 2a, these two will get cancelled. So we get a raised to 2n plus 2 plus b raised to 2n plus 2 is equal to a raised to 2n plus 1 into b plus a into b raised to 2n plus 1. Now the next step, you bring the powers of a, terms with powers of a to one side and terms with powers of b to other side. So that is a raised to 2n plus 2 with the powers of a, here we have minus a raised to 2n plus 1 into b equal to terms with b, powers of b, you take it to other side. So ab 2 raised to n plus 1 minus b raised to 2n plus 2. Is it okay? Up to this, is it clear? Is it okay? Don't write, children. I'll give time for copying. First listen. First follow this one. Is it okay? After this, you tell me. After that, okay. After that, you can copy it. Up to this, is it okay? I'll explain it once again from the beginning. Okay. Look at here. It is given a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is the geometric mean of a and b. It is given, this is the geometric mean. For the geometric mean, what is the formula? It is root of ab. Okay, geometric mean of two numbers is given by root of ab. So a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is root ab. In order to remove the root, what we do? We are squaring. When you square it, left hand side, we will get the whole square equal to AB. Next step, we expand the left hand side. We expand the left hand side using the identity A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square by Similarly, for the denominator, a square plus b square plus 2ab is ab. Power to power means we know that multiply the powers. So it will become a raised to 2n plus 1 plus 2a raised to n plus 1, b raised to n plus 1 plus, again here, power to power. It is b raised to 2 into n plus 1 by a raised to 2n. Here also again the same, a raised to n, the whole square. That means the powers to be multiplied. So a raised to 2n plus 2a raised to n, b raised to n plus 2b2 raised to n is equal to ab. Up to this step, is it clear? Is it okay? It is given as geometric progression. We apply the definition that is equivalent to root AB. We square on both the sides. We expand it using the identity a plus b the whole square. Up to that, is it okay? Where is John Philip? Is it okay up to that step?
Yes, ma'am.
What about the others? Vinayak, Jees, Sanjana, Roseanne? Is it okay? Yes, Sanjana? Is it clear?
Yes, ma'am.
Up to that step, is it okay? Naureen, Pooja?
Yes, ma'am.
Okay, now look at the next step. Next step, what we are doing here, we cross multiply. We cross multiply. When we cross multiply, the denominator will be going with the new. Okay, we multiply this term with the denominator. That is why I put one arrow here. Okay, this denominator will go to the numerator. So in the numerator, look at here, a raised to 2n plus 1. When we open the bracket, it will become a raised to 2n plus 2 plus the second term as such plus 2b into 2 raised to n plus 2 is equal to, here when we multiply a raised to 2n into ab, a raised to 2n into ab means we have to add the powers, isn't it? When we multiply, we'll add the powers. A raised to 2n is here it is a means power is 1, so we'll get a raised to 2n plus 1 into b plus, take the second term, 2a raised to n b raised to n into ab. It will become 2 into a raised to n plus 1, b raised to n plus 1 plus b raised to 2n if you multiply, b raised to 2n into ab. So a into b raised to 2n plus 1. Is it okay? John Philip, is it okay?
Yes, ma'am.
The next step, what we do here we have both the same terms we have. One is in the left hand side, the other term is in the right hand side. Both are of the same sign. So what we can do, can we cancel these two? Because when we bring it to one side, one will be positive, other will be negative. So we cancel it. Is it okay? And Mary? Now look at the next step. What we do after cancelling, we bring the terms with powers of a with one side and the terms with powers of b to other side. Here b is here means there is no power. So we bring the terms with powers of a to one side and the terms with powers of b to other side. Is it okay, Meherin? John Philip?
Yes, ma'am.
Yes, ma'am.
Atulya?
Yes, ma'am.
Jewel? Okay.
Yes, ma'am.
Now look at the next step. Look at the next step. So the next step is from these two terms, I'm going to take something as common. Okay, suppose we have like this, ab square minus a square b. What you can take as common? A square b minus ab square means what we can take as common from these two terms?
AB.
AB. Okay, we will be whenever we take common, we take with the smaller power outside. Here a is here, a square is here. The smaller power is a raised to 1, isn't it? Similarly, b square is here, b is there. So which is the smaller power? B raised to 1. So whenever we take common, we take the smaller power only outside. So here also we have a raised to 2n plus 2, a raised to 2n plus 1. So which one we can take outside? We can take a raised to 2n plus 1 outside. Is or no? A raised to 2n plus 1 outside. The smaller power, 2n plus 2, 2n plus 1. Which is smaller among these two? 2n plus 1 is smaller, isn't it? If you take that outside, you'll get a minus b equivalent to. Again here, the smaller power. b raised to 2n plus 1 is smaller. So if you take this, you'll get a minus b. Is it okay? Is it okay? Navneet?
Yes, ma'am.
Renil?
Yes, ma'am.
Now both the sides you divide by a minus b. So we get a raised to 2n plus 1 is equal to b raised to 2n plus 1. Okay. So next step, again, you divide both the sides by b raised to 2n plus 1. Divide both the sides by b raised to 2n plus 1. So we get a raised to 2n plus 1 by b raised to 2n plus 1 is 1. It is equivalent to 1. That is, we can write this as a by b raised to 2n plus 1 is 1. 1 means we can write this as a by b raised to 0. 1 means we can write this as a by b raised to 0. So a by b raised to 2n plus 1 is a by b raised to 0. Base is same. That means powers must be equal. 2n plus 1 is 0. So we get 2n is equal to minus 1. So n is minus 1 by 2. For finding n, only we are writing this much steps. N is, the value is minus 1 by 2. Is it okay? Is it clear? Is it okay?
Yes.
Okay. Okay, I'll show the screen from the beginning. Start writing. Okay. Yes, children, start writing. Roshan Rashid is present. Roshan. Roshan. See, once you finish writing, you tell me. Okay. Finished? Up to this part, is it over, children? If you next, okay. Okay, if you want to scroll, you just tell me, then only I'll be able to understand. Okay, don't keep. Okay, today do this question once again. Do this question once again as homework. Okay, same question as homework. It's an important question. Atulya? Okay.
Yes, ma'am.
Now is it okay now this part?
Yes.
Okay. Write this. Anashwarya? Jyoti? Any doubt in this question? Anashwarya? Jyoti?
No, ma'am.
Valentina? Is it over? Jewel? Finished? And Mary?
Yes, ma'am.
Okay. So, okay. Is it okay, Pranav? Completed? Pooja? Anaga? Okay. See, in order to do the next question, for solving the next question, we need one formula that you have learned in our 10th standard. Okay. Suppose two zeros are given, formation of polynomials. Okay. If suppose two zeros are given, what is the formula to form the polynomial? What is the formula we have learned? Zeros are given. Polynomial is given by, what is the formula? Meherin?
And I forgot.
Let me see. Yeah, we'll be giving the answer. Valentina, Malavika, Shabarinath. There is Vinay. Vinay is present. No. Yes, Shabarinath.
Sum of zeros equal to minus b by a.
Okay.
Product is equal to c by a.
Okay. So suppose the polynomial is ax square plus bx plus c. Then sum of the zeros is a no. Sum of the zeros, alpha plus beta is minus b by a, and the product is c by a. Alpha beta is c by a. This is the relation. Okay, this gives the relation. My question is, if zeros are given, if alpha and beta are zeros, then what is the polynomial?
K into alpha plus beta x plus
Yes.
alpha beta.
K into x square minus x into alpha plus beta plus alpha beta, isn't it? What is the formula we have learned? K into x square minus x into sum of the zeros plus products. Okay, this formula we need for solving the next two questions. Write down this one. Okay, relation between zeros and coefficients of a polynomial. Relation between zeros and coefficients of a quadratic polynomial. So if zeros are alpha and beta, then the polynomial is given by k into x square minus x into sum plus product. Okay. So with this, we conclude today's session. Learn the formula and come. Okay, within one more period. By Monday, I think Monday we'll get one period. By that period, we'll be completing this chapter, geometric progression. Sequence and series will get over. The questions which we are discussing in GP are 4-mark questions, 5-mark questions. Okay. The questions which we discussed earlier are also important 4-mark question. Okay, children. Is it okay? Copied? Pavitra? Okay, children. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.